for the three-phase, let's say, for example, this one, it's at T0, for example, T times 0 here, the voltage is bigger than the other ones. So the current will circulate from VA. Do you follow me, guys?
We're here. Yes, doctor.
Okay, so yeah, thank you. So this current will serve through the first diode. Okay, it has two paths. This one and the one the bottom here. The bottom it has like a cathode here, so it's blocked. This diode will block the circulation here. So the current will be having only this this direction to follow, and here also it has another intersection. So here also you will find this D3 and D5 block. It will continue toward this and it will generate this voltage across that resistor or this load. And coming back here, it has three effectively. It has three ways to go from them, because they are anode from that side, and it can be open. But now, which one of them? It depends on the this time here. It depends on which of these is less one, because look, it's like a DC source, plus and minus. We never have like plus and plus or minus and minus. So usually you have high potential and low potential to get our current coming back through the low potential. So that's why here at this point, that current will look for which phase here is the lowest one compared to the other ones. Okay, if we can check, for example, you can see here that the second curve here, from this point to this point here, okay, we have A, that is the biggest one. Look here, this A here, this is the biggest one compared to VC and VB. So that's why the D1 will be conducting at the beginning. And in the same interval, we have B, which is the lowest one. Because here, C, it's bigger than B at this interval. So the current will look for B, the diode connected to B, which is D4. So here, it will continue here and come through this diode and go back here, like that. Okay, now the other interval, still A, it's bigger, so the current will again continue circulating from A, coming through this resistor. And in this interval, we have now C, which is lowest one, the smallest one. So this will be blocked, this D4, and the C, which is D6. Sorry, so the current will come here and go back here. Okay. So as you can see, for each 60 degree, okay, the one diode is one pair of diode is conducting. Okay, of diode. Pair of diode means for our case was D1 and D4. Okay, this is 60 degree. Another 60 degree, we have D1 also, and the D6. So if you can see, if you can, join all of these, or just check for each diode by itself. So the diode will conduct 120 degree. Okay, like this time and this time here, 60 and 60 degree in terms of time. Let's see. So each diode will conduct 120 degree, but pair of diode will conduct only 60 degree. D1, D4, D1, D6, D1, the D, 3 and 2, like that. Okay, so every two diodes they will conduct only 60 degree, and each diode by itself will conduct 120 degree. And you can see it here. For example, from this point to this point, and those are 120. If you add 120 to this, will be 270. So during this 120, we have B. The diode connected to B will be conducting this time. But the pair of diodes, which is B and C, diodes, this is 60 degree, or B and A, 60 degree. I hope you got the idea how this works here and how the diodes they conduct. And you have the three-phase system in front of you. You can easily identify one by one. Okay, so each 60 degree, we have two pair of diodes, one here and one here. The one connected to C and the one connected to B, for example, for this case, to A, sorry. So C, which is D5. So at this time, the current will come from here and go through D5, okay, resistor, and come back through D2, that is A, phase A, and so on. So for the whole till we switch off our system, it will be doing like this. Just keep in your mind, the current will start from the biggest phase and go back from the lowest one. Yes, sir. You need to ask.
I was wondering, can you repeat the last point?
Which one here for C? This one here?
Yes.
Yeah. Look, from here, we just delete this part here, so we can from here, from this intersection to this intersection here. So this interval, we have to look for the biggest phase and the lowest phase, plus and minus. Keep in your mind the DC source, plus minus. Okay, so we look for plus. So this for this interval we have VC as a plus. The minus for this DC, for example, we have it for this interval VA. That's VA. The currents go through VC, but which diode is connected to VC? Forget those ones here, the bottom ones, because they have cathodes. They will block any circulation coming from any one of those phases toward the load. But they will the other ones in the top, they will allow that current coming from in one of those phases and going from the top side of this load. So I told you here we have VC to be the highest one. So the current will come from here. Okay, and because this one is connected, D5 and D6, they are connected to VC. I told you D6 will be blocked, so D5 will be the one conducting at this time. Okay, coming here, this diode, this current, sorry, we'll see three diodes ready to be open. So, but now at this time, which one will be open? The one connected to the lowest one, the smallest phase. The smallest phase is A. So A is connected to D2. Okay, so this current will bypass D6, D5, D4, and come through D2 and come back through this phase here. So we start from VC, like this, come back through D2, sorry, and go back to that VA. Clear?
Yes.
You can take any example and you can check. Here we'll be having D1 and that's C, right? So C connected to D6. So D6 this time, D1, D6. Here, this is B, so D3 and D6 and so on. Okay, so that's why you can see here, you know, this those because those curves here, they are phase VA only. Okay, reference to neutral. This is phases or phase signals. not face-to-phase. Those ones are face-to-phase. Okay, this is phase VA, face-to-phase, VB, VA, VB, VC, and so on. That's why here we see 3 of them, but here we see double of them, like 6 in each time. In each, you know, if we take 1 sequence, this one doesn't work. If we take sequence from here to here for VA, for example, we'll be having 1, 2, 3, 4, 5. Half of this and half of this will make 6. So 6 phases. Sorry, not 6 phases, but 6 voltages, which are phase to phase, and so on like that. So, is it clear, guys, before I continue?
Yes, doctor.
Yeah. Now, this is my system. This is the rectifier connected to a 3-phase AC voltage here. The other side, okay, we'll be having our load connected here, but the signal coming here will be the one you see like that, this one here. Okay, so this one, if you keep it like this, that's we can calculate the average of that, and you have a formula to calculate the average, okay, of this this output voltage at this point here. If you need to go to get the maximum voltage, okay, the maximum, not the average of that, but the maximum of this, okay, just to increase the power at the output, we have to install a capacitor here. Okay, so this capacitor will be charged. Let's say if you have something like this, so on. You just do one thing again. Okay, so the capacitor will be charging like this. If we start, for example, at this time, it will discharge. It depends now on this tau, which is RC, at the time to discharge our capacitor. Okay, if we increase, this will be fixed. For example, this is the load. If we increase the value of the capacitor, so it will take time to discharge. And by doing this, we can go toward the, let's say, DC line. Okay, so to have a pure DC line, we have to increase the value of this capacitor. But of course, we'll never reach that DC line in perfectly in practical parts. But at least we can have our average V out, the one. We'll go to the maximum of V max for those, let's say AC, for example, or face-to-phase. Those maxes here, the max here. Okay, so by doing this, we can increase, as I told you, the power at the output, the P out here. Okay, if this is smaller, this capacitor, so it will do like this, and so on. And it will be smaller than the maximum, bigger than the one before without any capacitor, but smaller than if you increase the value of the capacitor just to increase the time of discharge and give time to this to reach the other maximum and decrease the ripples, the voltage ripple. I think I have covered everything. I didn't touch the formulas and how you can find the formulas. This is, you have it in your lecture and the textbook. For our case, and just to you know, explain the philosophy of this, how it works, and after that, give you our exercise that should be done and what you are requested to do in your lab report. So this should be done in Simulink. You have a 3-phase, okay, 127 RMS, 60 Hertz It's Y connected supply. Okay, so I have access to you can do like three single phases like this, connect them in Y connection and get access to the neutral. You can use it in your system. So this is your AC to DC converter. And the other side, you have your load can be connected like this. Is that correct?
So the circuit will look like the schematic, right? Diagram you showed earlier.
No. That's why I asked. This should be connected here to the, but you can use this this neutral after if you need to use it, if you want to use it, because this should be. You remember I told you the load, and I did this mistake just to check if you are following me. Sorry about this. Here I told you this should look for the other phase to the current. Okay, the current coming from here should look for the lowest phase, not neutral. If we do the neutral, nothing will work. If I connected here to the neutral, I'm bypassing the diodes, and the current will be going from the other side to those phases. So this is not to be done. Okay, your load will be connected to the rectifier. Clear, guys? Okay, so do the simulation and you have to calculate. This is the calculation part. You have to calculate the average voltage. You have a formula for that, for the three-phase rectifier. And the current also going through this resistor. At the beginning, we have resistor as load. Yeah, 150 ohms. Okay, so calculation will be here, will be done for taking into consideration R load. You have to plot those three curves, and after that, look here. I didn't ask you to add capacitor, but you can add it if you like, because here you will get something like that as a voltage here, the voltage at the load. Yeah, because here you should do those phases, three phases. This is what is requested here, the first part. The second part, you get with another color, you will get the phases on the top of this. The V out on the top of those phases. You display the current in the load side, in the source side. You put a meter here to display that current. For example, phase 1, you take only one phase. And the load current, which is here also. Okay, now for the measurement, you have to put like some blocks from Simulink to display the value of a V out. I'm talking about the value, not the signal. Okay, so the value for V out. Look for in Simulink you'll find the block in there, and the RMS value also, the current average and the RMS also. Input current, you take only phase A, for example, to calculate that the current, to display the current coming here in that phase. VEN. So here you will need that neutral to display, to measure VEN. And the power in the load here. Okay, also same thing. Look a little bit for the average here, means the active power. Look in internet how you can use in Simulink, you can use display this power. You can use voltage and current, multiply them. You can use a block ready made for the power, and after that you have to repeat from 1 here, not 2. From 1, you have to connect, keep the R 150. I'm going to update this. Now this lab manual, 150 ohms. in series with that in this inductor here, and you repeat those calculations. Do you have any questions, guys?
Yes, engineer, please.
Yes.
For the first, the calculation is made by hand. Yes. So
Yes,
I
yes.
mean, yeah. Okay.
This part here by hand.
Yes. Okay.
Engineer will show us in Simulink or no? The circuit.
No, I don't have one.
Okay. we have to submit also the Simulink file, right?
Yes, please.
Okay.
It's easy. You have 4 diodes. It will take time to open my, MATLAB. But there you'll find a 3-phase block. Okay, you have just to enter some information parameters in the block, or you can construct one by yourself. You take a single phase AC source and connect them in Y connection. Okay, in Y connection like this. And here you can connect your ground, so you can use it after to display VAN, for example. For the diode also, this rectifier, you will find one also ready-made, but I think it's useful if you build this one by yourself. The source, the wire by yourself, it will you learn more. Okay, for this one here, it's already made inside. You have just to enter parameters and that's it. But this will not give you more information on how it works. In terms of, you can check diode by diode and check the currents there inside. You just check if this is open, this still opening. I think the rectifier, it's easy. So next time, yeah, I just remember one thing regarding the common labs. This one here, this what we call uncontrolled rectifier. Where is it? Next session will change the diode by thyristors. We'll add the thyristors here with the control, part, and there we can control one by one according to for how long we need this phase to be on and the other one and so on. I think this is you have done this in the lecture, right?
For the thyristor, not yet, but for the 3-phase rectifier using diodes, we did it.
So controlled rectifier, not yet, right?
No.
Yeah. So thank you for saying that, because this is what I told you at the beginning. For me, if you are not here and you don't tell me, I will explain the control like you have to, you took this before. So now, since you told me you don't, I mean you didn't take this, I'm going to explain it another way, an easiest way and more clear. Do you get my point? If you don't tell me, I will explain it like in general. But now I'm going to explain in details a little bit how it works perfectly, that controlled rectifier with thyristors. Okay, I was talking about the ready-made ones and the ones you can make by yourself. Give me another 5 minutes and you can stop. I think we have to stop now, but give me 5 more minutes and we'll stop, inshallah. So say in sources. Go to sources here. I need to remove this. No.
Engineer, what is the benefit of this clock one? This one, the clock.
Where is clock?
This one, the circled one, and its name is clock. In the first row, the third column. First row, third column.
Okay, I don't see because I have this recording part in front of me, but you know this this clock in Simulink is it's collecting data according to the time of simulation, and this will be sent to MATLAB to use it in MATLAB. I don't know if you get my point, Mohammed, صح? Mohammed Shaldan?
Yes, I understood. So it connects the data with the simulation time.
Yes, it will collect the data at that time. So you know, have you used MATLAB, not Simulink, MATLAB, to plot any signal, for example? Have you used that before?
The clock we didn't use, but
No. Forget the clock. In MATLAB.
using coding, yes, we plot the graph.
So to plot the graph, you create a vector time vector, right? Or X, for example.
Yes.
So in X, now this is the clock. This is a clock here in Simulink. It's X in or time vector in MATLAB. It's like you type in MATLAB T and double dot equal, and you give the starting and step and the finishing time. Right? This is what you do, right?
Yeah.
So this clock, it's same as that. It's doing exactly the same thing. So once you go back to MATLAB and you say just plot y, for example, so he knows that this y will be referenced to a time which is clock, because he already collected that information from Simulink through this clock block. Okay.
Okay, thank you, engineer. Clear.
I think it's the voltage. You will find the block here for sine wave. It's called power sine.
Here it is, engineer, the sine wave.
Not that.
Okay.
Don't need that. So it's. I need the one like not here. No, let me go to SimCap. Something like this, AC voltage. Okay. Yeah, this one. Okay, so we have this, and we have also the other one, which is three-phase. This one here. Okay, let me come here. Look, you can build your three-phase by duplicating this 3 times. This will be, for example, let's say it depends on this is a V amplitude, which is 127 times this is a peak, so times root of 2. صح?
Yes.
Okay, and phase will be, will be our phase A, so 0 degree, the frequency 60, for example, and this will be the same thing. Let me just do one thing and delete these and duplicate again. So I will be having only one parameter to change. This is already copied. This will be 120 in degree, and this will be either 120, sorry, minus 120 or plus 240.
Here you're following negative sequence? No.
You can do the other. You can do the other. No problem. Just I'm not doing my blog. I'm not doing my exercise now here. I'm just showing you what you can do. So this will be minus. If you need your sequence, this will be minus, and this will be plus 120. Okay. Anyways, that will create our three-phase. Or you can use this. So here we'll be having this something like this, and they can connect my ground here. So this block, which is this block also, but this block is already made. You have just to double click on it, and here they're asking you to put here phase to phase RMS. Keep in mind the one I gave, it's 127 phase only. Should be phase to phase, so we have to convert the other one to phase to phase, and after that you can calculate. You can put it here. It's already given to you as RMS value, so no need to calculate except change it from phase to phase to phase. Phase degree 120, so it will be shifted 120 each one of them, and 60 hertz. Okay, so if you need to use that instead of building one from using by you, and I think once it's done, you can even create your block to be your block like this. How we can do that? Create subsystem. So this will be my subsystem now. Just to connect my rectifier here. Okay. The rectifier also you can use diodes, or you can use, I think one it's rectifier. So the TAN, which one of them? This is a controlled one, thyristor's rectifier. We have only, yeah, this one, I think. You just check this. Yeah, here.